One of the more exciting types of SQL CLR code modules is custom aggregates. Earlier versions of SQL Server didn't offer an easy way to extend the rather short list of T-SQL aggregates, such as sum, average, max, min, and count. You still can't use Transact SQL to create custom aggregates, but you can write your own in SQL CLR. It's not something you'll need to do often, but it can greatly simplify application coding in situations where you need it. Unlike other SQL CLR code modules, you can define only a single custom aggregate within a class. The class has to be public and requires 4 non-static methods, which SQL Server calls as it processes the data to aggregate. Init initializes storage values. So you can kind of think of this as the constructor of the aggregate object. SQL Server calls this once at the beginning of the query that uses the aggregate. Accumulate does the work of combining values. SQL Server calls it once for each row that is aggregated, and it has to support multiple instances of the aggregation code that's executing so that SQL Server can utilize multiple threads to make operations more efficient. And then, merge is called at the end of the operation to merge the aggregations of multiple instances into one final value. And finally, terminate is the last method called and returns the final aggregated value. You also have to deal with serialization issues because instances of the aggregation class have to be moved between threads. This complicates the code only a little because the .NET Framework has such rich support for serialization. Most commonly, you'll implement the iBinary serialize interface to let .NET do all the serialization work, but there are other options if you have a special need. Consider a simple aggregation. A common requirement in applications is to create a concatenation of strings within a table, delimited by a single character, such as a semicolon. Some applications require information in this format for processing. So what I've done is create a concatenate aggregation that you can use to concatenate all string values in a field. For example, once you create the aggregation, you could run some Transact SQL code that looks like this in order to produce a single string with all the product names from the Northwind products table that have a category ID of 4, which is dairy products. All right, so let's take a look at the code that can implement that kind of a concatenation. Keep in mind that we can only have a single aggregation in each class. You can have multiple classes in a single file, but only a single aggregation per class. All right, so the first part of the code here defines the aggregation class and decorates it with serializable, so that takes care of the serialization features, and then also provides the SQL user-defined aggregate attribute. This attribute requires several parameters, most of which the query processor uses in order to perform the aggregation properly. The first one is format. This specifies the serialization format, and your choices are either format.native or format.user-defined. You'll nearly always need to use user-defined, although SQL Server has enhanced support for the native format. The next one is invariant to duplicates. This indicates whether the aggregation result is the same if any of the items are duplicates. In the case of the concatenate aggregation, it returns a different result if duplicates exist, because they'll appear multiple times in the resulting string. So for concatenate, this is set to false. And then the next one is invariant to nulls. This indicates whether the aggregation result is the same if any of the items are nulls. Concatenate ignores null values, so this value is set to true because the same string will result whether there are nulls or not. Next one is null if empty. This indicates whether the aggregation result is null if no items were aggregated, such as when the where clause returns no records to aggregate. If no strings exist, concatenate returns a null, so this is set to true. And then finally is the max byte size. This is required by the user-defined serialization format and indicates the largest aggregation value that can be returned. And so in concatenate, this is set to 8,000 bytes. All right, so here's the actual concatenate class, or in this case, it's implemented as a struct. It inherits from ibinary serialize so that SQL Server can properly use multiple instances of the aggregate. Okay, so now we need to start implementing the code. We need a place to contain the string that we're building during the course of concatenating different strings together. So this code uses a .NET Framework string builder object, a very fast and efficient way in order to concatenate strings or bring them together. And then here's the code for the init method. Remember, this is one of the required methods of a custom aggregation. And the only thing we need to do here is instantiate a new string builder object and assign it to that SB variable. Next up is the accumulate method. SQL Server is going to call this method when it has a new value to add to the aggregation. Concatenate works only on string type data, so it receives a parameter of type SQL string. Then it tests to see if the value is null. If the value is null, it returns immediately. There's nothing to do because concatenate ignores nulls, like most of the built-in aggregate functions. Otherwise, it's going to append the string to the string builder and add the trailing semicolon. So that's the code that's going to execute each time SQL Server has a new value that we need to incorporate into the aggregation. All right, the next up is the merge method. This is used to aggregate multiple instances of the concatenate object. In many kinds of custom aggregations, this can be some very, very complex code. It just depends on the type of aggregation being done and what you need to do in order to merge two of these concatenate objects together. But in this case, it simply concatenates the value passed to it to the current instance's aggregation value. So it's just using that object's SB variable, which is available here, converting it to a string, and concatenating on the semicolon. So a very simple operation for string concatenation. Now this would be more complex if, for example, we needed the resulting strings to be in alphabetical order. So in that case, I probably wouldn't use a string builder object. I'd use some sort of sortable .NET list object in order to store the strings internally while processing the aggregate. But this is all that's needed here. Okay, then terminate is the last of the 4 required aggregation methods. SQL Server calls this after it processes the last value that it needs to aggregate. So this method needs to return the final aggregated value. So the code first checks to see whether there's anything that's been concatenated. If the length is equal to 0, that means that no strings have been concatenated, and it just returns a null value. Otherwise, it strips off the trailing semicolon, converts it to a string, and that is the result value. And it returns that result. It also clears the SB object in case this instance of concatenate is used for another aggregation, because sometimes SQL Server will keep objects in memory and reuse them as a way of enhancing performance. Okay, then there are 2 other methods down here, and these are both part of this ibinary serialize interface. The read method is called when the object is deserialized and restores the value of the SB variable. In this case, all it needs to do is it gets this binary reader, and it just has to convert that to a string, and it returns that as part of a new string builder object. So again, this is the code that executes when SQL Server needs to create a new instance of the object and rehydrate it from its serialized form. And then the write method does the opposite thing. It provides a binary writer, and then all we need to do is use the write method of that binary writer and send the string form of that string builder object, and that takes care of the serialization. So that's one of the benefits of using the binary serialization that's built into the .NET framework. The code that we have to implement for our objects is very, very simple. All right, so the next thing we need to do is build this object, build successfully, and then publish it. I'll load up the profile. I'll use Northwind in this case, and publish it. Okay, and it published successfully. Now we can go back over to our Transact SQL code. I'll use the Northwind database, and we'll concatenate all the product names from the products table within the Northwind database. I'll execute that, and there's the resulting string. So we have product name, semicolon, product name, semicolon, and so forth. So this is a pretty simple but useful example that shows why it's necessary to create a SQL CLR aggregate. Other custom aggregates may require more complex code to implement all the required features. And you may have to use multiple class-level variables to keep track of multiple values during the course of calculation. But it really isn't all that hard to do once you understand the basic principles. You'll need to have a good handle on how .NET does serialization. But these techniques really become valuable when you implement your own user-defined types in SQL CLR, which opens up whole worlds of possibilities within SQL Server. Back when SQL CLR aggregates were first introduced in SQL Server 2005, the total size of a SQL CLR aggregate was limited to 8,000 bytes. In many cases, this is more than enough for the data that you're aggregating. For example, if you're aggregating data into a single numeric scalar value, like the built-in sum, average, and other aggregates, you really just need to store an integer or floating point value. But what if you use the concatenate aggregate on a large product table, such as the one in the AdventureWorks databases? Unless you limit the rows that the aggregation includes, you'd quickly get an overflow error if you were limited to just 8,000 bytes. The good news is that SQL Server 2008 eased that size limitation, bumping it way up to 2 gigabytes, which is the current limit. Frankly, if you're aggregating something that requires more space than that, you might want to rethink what you're trying to accomplish. But now it's possible to create a version of the concatenate aggregate that can hold reasonably large strings while processing large number of records. But in this example, you're going to see that this is a case where there is a data conversion issue between SQL type values and CLR values. The issue is that the SQL string type used in the concatenate aggregation has a limit of about 8,000 bytes. That clearly isn't going to do for the larger strings that we're going to want to have large concatenate handle. So the code is going to use the SQL chars as the data type returned by the aggregation. This is roughly equivalent to an n-varchar max, which is the largest string object in SQL Server. Within .NET code, SQL chars is essentially a char array. Internally, the code can still use a string builder object to handle the aggregated string, since that object supports a virtually unlimited string size. The main thing you need to do in order to change the SQL CLR code, besides that data type issue, is to identify the aggregate as a large aggregate, and you do that by changing the max byte size value of the SQL user-defined aggregate attribute to -1. Here's the code for the large concatenate class. As far as the attribute goes, the only change here is a change from 8,000 bytes to -1. And again, that's what tells SQL Server that this is a large concatenation. The rest of the code in the class is generally similar to the concatenate class, except that the code has changes to accommodate the use of SQL chars instead of SQL string. It also implements a few other things differently, particularly in the way it handles nulls. And for variety, it delimits the strings with a vertical bar character instead of a semicolon. As I mentioned, once again, it uses a string builder object in order to handle the actual concatenation internally. And that's within the SB variable. We have the init method, same as concatenate, it just news up the string builder. Okay, the code gets a little bit different from the concatenate version with the accumulate method. Because this method receives a potentially large string from SQL Server, the parameter here is of type SQL chars. This is another one of the SQL types, data types. And then the code has to essentially manipulate a character array. So the code starts by creating a regular string variable called value. And then it news up a string and reads the value property of this object, the SQL chars object. This returns a char array. And then, so that property returns the char array. When you pass a char array to a string constructor, it converts it to a string. So very convenient features of the .NET framework. Okay, then the code verifies, checks to see whether or not the value is null, and that it's not an empty string. And if both of those conditions are satisfied, then it appends that string to the string builder. So conceptually the same, but this code has to accommodate the fact that it's using a SQL chars instead of a SQL string. All right, here's the merge code. This code is pretty much identical to that of concatenate, other than it receives a large concatenate object, because this needs to receive the same kind of object, a large concatenate object. In this case, it's only manipulating that internal SB variable, the string builder object. So we don't have to do any conversion, we don't have to change the code in order to accommodate the SQL chars, because this is all happening within the .NET code. All right, then the terminate is different because it needs to return a SQL chars object. Fortunately, that's also very simple. I can get the string from the string builder object, pass that to the constructor of SQL chars, and that converts that string into what is virtually a char array. Okay, then we have the ibinary serializable members. And this is identical code because once again, it only has to work with the internal string builder object. So this code, this read and write methods, are identical to that in concatenate. All right, this is the same project as contains concatenate, so it's already deployed. So I can go over here and use the AdventureWorks 2012 database, and I can execute this method. And I also include the transact SQL code here if you want to deploy it using Management Studio. Okay, so I'll execute that. Whoops. Oh, no, I was wrong. I deployed it earlier to the Northwind database, but I need to deploy it to the AdventureWorks database. Fortunately, I have a profile for that right there. So it's going to deploy to the AdventureWorks 2012 database and publish it. Okay, successfully published, and now we can execute the code. And this will take a few seconds to execute. There's a lot of rows in the table. All right, so we get a result. And as you can see, it took about 19 seconds on this relatively speedy machine. And we can expand this. And you can see all the first names because we're concatenating the first names from the person table. So we have that name and Catherine and Kim and Kim and Kim, 3 Kims, and Hazim and Sam and Umberto and Gustavo and so forth. But there's a little bit of a problem. If we scroll all the way to the right here, we see there's an awful lot of names. But we don't see all of them. There's a little ellipsis right there. So Management Studio isn't able to display the full string. And this is just a limitation of Management Studio. The aggregate returned the full string, but Management Studio truncates it and just replaces the remaining data with that ellipsis. So if I was calling this from a real application, able to get this large string, however large it is, then we could deal with it. But Management Studio just truncates it because of the user interface. So what we can do instead is execute the method this way, save the value to the concat names, and then print the length of it. So at least we get an idea of the length of this string that was generated. So I'll go ahead and execute that again. And it takes roughly the same amount of time to execute the aggregation. And as you can see, there's 137,882 characters in that resulting string. So a fairly large string, but fortunately far from the maximum string length. So the idea here is that clearly this aggregate returns far more than the old limit of 8,000 bytes. SQL Server provides a nice enhancement to SQL CLR aggregates with support for multi-parameter aggregates. A multi-parameter aggregate lets you pass more than one value to the aggregate, which the aggregate object processes or compares in order to calculate the final aggregate value. For example, suppose that you have two columns of date values within a table, and you need to find the latest date in either of the column across all rows. So again, you have two columns, a whole bunch of rows, and you need to find what the maximum date is, the latest date, anywhere in either of those columns. In older versions of SQL Server, you'd probably calculate the maximum value for each column and then compare those values to find the absolute maximum, which is a two-step operation within your Transact SQL code. Now you can implement a multi-parameter aggregate by passing the parameters to the accumulate method in the aggregate class. Then within that method, you can include code to process the values and update the aggregate value as necessary. An important feature here is how the sample handles nulls. If either of the date values is null, you can't compare them, and the accumulate method simply returns without doing any work. Otherwise, it compares the two dates and then compares the latest of those two to the current value stored in the max date variable. Here's the code for this max date aggregation. It's once again in a structure, and it's decorated with the SQL user-defined aggregate. In this case, I used a SQL date time value, so I don't have to do any kind of conversion when I return the value to SQL Server. Here's a init. I just need to set the SQL date time value to null. Okay. And now here's the accumulate method. This is what's new with this. I can include multiple parameters. So I'm going to compare two dates, so I have a space for two different SQL date time values, because SQL Server is going to pass those values to this method. Now, if I needed to compare more than two dates, I would need to include the parameters, but then also the logic starts getting a little bit more convoluted as well. Now, we can't compare if either date is null, so we're just going to return there. This is an area where this code could be enhanced somewhat, because it's possible that one of those dates could end up actually being the maximum value. But I'm keeping the code fairly simple here. All right, then instantiate a new SQL datetime value, and then do the comparison. If datetime value 1 is greater than 2, then I return 1, otherwise I return 2, just using that C# ternary operator. And then I check to see if the max date is current, that's the running maximum date, is null, or if this datetime value is later than max date, and if either of those conditions apply, I then update max date with what is now the latest date that the aggregate has found so far. All right, so here's the code for merge. It's going to get a max date object passed to it, and then first of all checks to see if max date is null, or if the group max date is null or not, and whether or not max date is less than the current value. So in other words, checks to see if it's null. If it is null, then it goes ahead and updates the value, calls the terminate method on that group object. And otherwise, it's going to update the current max date with the value from group if the value from group is later than max date. Okay, so a little bit of logic to think through. And then all terminate needs to do is return that max date value. All right, so now we can go back over here and test it. So here's the max date. And it's going to operate on the sales order header because sales order header has an order date and a ship date column. I'll execute that, and we can see that August 7th, 2008 is the latest date within those two columns throughout that entire table.